Mr. Moore's math class! Good afternoon, guys, and welcome to Mr. Moore's online flip classroom. And I am super excited today because we've got a very big lesson. We're going to be learning all about how to solve quadratic equations. Now, in the past, what we've done is we've actually learned how to factorize quadratic expressions, and these skills are going to be vital for what you're going to be covering today. So let's not wait any longer and let's get stuck straight into the lesson. Now, when we solve quadratic equations, there's a few steps that we must follow in order to be able to get the desired answer. So let's check these out. Now, step one is to get everything on one side of the equal sign so that you're just left with 0 on the other side of the equal sign. So let's check that out.
When solving quadratic equations, we need to make sure that we have everything on one side of the equal sign so that the other side of the equal sign is equal to 0. In this example, I've got 2x squared plus 4x equals 5. So as you can see, I need to move the 5 over to the other side by making it negative 5. And for this example here, I've got x squared equals 2x squared minus 3x plus 2. So as you can see, I need to move the 2x squared over, making it negative 2x squared. And then I combine the like terms with x squared minus 2x squared, getting us negative x squared. Moving over the negative 3x now gets us positive 3x. And of course the positive 4, moving that across, gets us negative 4, hence making the equation equal to 0.
Now, step two is to count how many types of x you have. For example, in the top and the middle equation that you can see here, I've actually got just one type of x. Whereas down the bottom equation, I've got two types of x. Now, if you have just one type of x, what you need to do is use BODMAS to solve. Whereas if you have two types of x, you actually need to go through and factorize in order to be able to solve. Now, we've already spent a number of lessons going over how to factorize, but let's just recap on what we've already learned. So when we factorize, we always need to make sure we look for any common factors first. Then what we need to do is we need to count how many terms we have in the equation that we're actually factorizing. Now, if our equation has two terms like what you can see here, you're going to need to go through a specific method in order to be able to factorize. So let's quickly check that out.
Now as you can see here, we've got two terms that need to be factorized. Now the very first step is to think about what squared will get you x squared, and we'll write that in the brackets, which you can see here. So we get x in brackets squared will give us x squared. The next thing is what squared will give us 9, so you get 3 in brackets squared will get us 9. You then label the a and the b, and you're going to substitute into the formula a plus b bracket a minus b, giving us x plus 3, x minus 3.
And if our equation has four terms like what you can see here, you're going to need to use this method in order to be able to factorize.
Checking out this example now, we have an expression with 4 terms. Now the very first step is to put brackets around the first 2 terms and brackets around the last 2 terms with a plus in the middle. We then need to factorize the first brackets by taking out 2x as a common factor, leaving us with x plus 1 inside the brackets. Factorizing the second one now, there are no common factors, so we just write plus 1 out the front. What you then notice is we've got the common binomial factor as highlighted by the orange here, and you write that down on the last line with your 2x plus 1 out the front of this as a bracket.
And quite regularly, you're going to have to solve equations with 3 terms. Now, they're either going to look like this or like this. That is, they're either going to have an a value out the front, or the a value will be 1, leaving us with nothing out the front of the x squared. Now, when it comes to solving these, you're going to have to factorize them using different methods. So let's check out how to factorize equations with 3 terms with an a value out the front quickly, shall we?
Factorizing 3 expressions now with an a value out the front of the x squared, that is in this case 2, what we need to do is we need to multiply the a value by the c value, so we need to multiply the 2 by the 2 as you can see here. This will end up giving us an answer of 4. Now what we need to do is find the factors of 4 that will add to 5, so if you have a look, the factors of 4 that add to 5 are 1 and 4. What we're going to do now is we're going to break up the 5x into these two factors, so we get 4x plus x, because we know 4x plus x is 5x, so it's essentially the same thing. Now we've got 4 terms, so we can go through and factorize as if it's 4 terms. So we group the first 2 terms together and the last 2 terms together. Then we need to factorize the first set of brackets, taking 2x out the front, leaving us with x plus 2 inside the brackets. Factorize the second lot of brackets now by taking out the common factors. Well, there aren't any, so we're going to use 1 as a common factor, leaving us with, once again, x plus 2 in the brackets. Now you can see the common binomial factor of x plus 2, so what we need to do is write out the 2x plus 1 in the first bracket and the x plus 2 in the second bracket. Hence we have now factorised 2x squared plus 5x plus 2.
And let's quickly have a recap on how to factorise equations with 3 terms but with nothing out the front of the x squared.
Factorising an expression with 3 terms and a coefficient of 1 for the x squared, what we need to do is we need to look for the factors of c, in this case being 20, that add to b, that is 9. So you go through and you write out all the factors of 20, being 1 and 20, 2 and 10, 4 and 5, 5 and 4, 10 and 2, and 20 and 1. And now what ones of these add to 9? Well, we know 4 plus 5 equals 9, so you write x plus 4 in one bracket and x plus 5 in the next bracket.
And the final step when solving for quadratic equations is to make whatever's inside each bracket equal to 0, giving us 2 mini equations. From here what you need to do is you go through and solve for x in each one of these little mini equations. Now this here is called the null factor law. Alright, so let's have a look at a couple of worked examples on how to apply the null factor law properly. Let's check it out.
Okay, so now it's time to have a look at solving quadratic equations, but before we do that, let's have a look at some of the steps involved with this process. Now stage 1 of this process is to see how many types of x we have. That is, if you've only got one x squared and no other types of x, then what we're going to do is we're going to solve using BODMAS. Whereas, if you've got an x squared and an x, what you're going to do is you're going to factorise and then follow the steps that you're about to see. And stage 2 of this process is to factorise. Now we do this first of all by checking for common factors and taking these out if there's any there, and then we check to see how many terms we have. So for example, if you've got 2 terms, you're going to solve using the method a squared minus b squared is equal to a plus b, a minus b. Whereas if you've got 3 terms, you've actually got 3 methods to solve. So for example, if you've got x squared plus bx plus c, that is there's no a out the front, what we do is look for the common factors of c that add to b. And if you do have an a out the front of the x squared, well then you're going to multiply a by c, and you're going to factorise as if you've got 4 terms after that. And of course, if you don't have a number out the front of the x squared, but there's no factors of c that add to b, then what we're going to do is we're going to complete the square. And finally, if you've got 4 terms, that is something like x minus 4y plus mx minus 4my, what you're going to do is you're going to separate the first 2 terms and separate the last 2 terms, and then look for a common binomial factor in order to factorise. And finally, stage 3 of this process is to make each factor equal to 0 and then solve for each factor separately.
Now in this worked example we're going to solve a couple of quadratic equations that have already been factorised for us, taking out a lot of the hard work. So let's go and check this out.
Okay, so now it's time to attempt a couple of worked examples on solving the following equations. So if we have a look here, the first question says x plus 5 times 7x minus 11 is equal to 0. Now what we've got here is we've actually already got it in factorised form, so we actually don't need to go through stages 1 and 2. All we need to do is stage 3, which is where we make each factor equal to 0 and then solve for each factor separately. So what we're going to do here is we're going to say x plus 5 is equal to 0 and 7x minus 11 is equal to 0. So we're going to solve for each factor separately, and in order to do that we're going to subtract 5 off each side for this one, and that will get us the 5's cancelling out, leaving us with x is equal to negative 5. For this one here we're going to add 11 to both sides, and that will get us 7x is equal to positive 11. Now when we divide both sides by 7, that leaves us with x is equal to 11 over 7. So essentially what that means is if I substitute in x equals negative 5 or x equals 11 over 7 into these equations, what I'm going to get is an answer of 0. For example, if I substitute in x equals negative 5 here, you get negative 5 plus 5 is equal to 0, and then whatever this is equal to here will end up getting you an answer of 0, because 0 times whatever is equal to 0. Whereas if I end up substituting in 11 over 7, so 11 over 7 plus 5 will get me something, alright? Whereas 7 times 11 over 7 will get me 11, and then you go 11 minus 11 will be 0. So that something times 0 will get you 0. So these are the two numbers for x that when you substitute in for x here, you'll end up getting an answer of 0. Now the next question says 2 times x plus 8 in brackets times 7 minus x in brackets is equal to 0. Now the big hint here is that we don't actually need to worry about the 2. All we need to do once again is make each factor equal to 0. And that is x plus 8 is equal to 0, or 7 minus x is equal to 0. Now to get the x on its own here, you're going to subtract 8 off both sides, and that will cancel out, leaving us with x is equal to negative 8. For this one here, you're going to subtract 7 off both sides first of all, meaning the 7's will cancel out, and that will leave us then with negative x is equal to negative 7. And now when we divide both sides by the negative, what you're going to end up getting is x is equal to positive 7. So if I substitute in negative 8 here, what you're going to get is 2 times 0, because negative 8 plus 8 is 0, times whatever happens to be here will be 0, because 2 times 0 times anything is 0. And if I substitute in 7, what I'm going to get is 2 times 7 plus 8 is 15, would be 30, but 7 minus 7 is equal to 0, so you get 30 times 0, of course, is equal to 0. So that means if I make x equal negative 8 or x equals 7, I get an answer of 0. Now what I want you to do is press pause and attempt the last question. Remember to press play once you're done and check your solutions against mine. Alright, so what I've done here is I've made each factor in the brackets equal to 0. So you've got 2x minus 1 is equal to 0 and 4 minus 3x is equal to 0. Now I've just solved for x, so I've gone plus 1 to both sides. We'll get the 1's to cancel out, leaving with 2x, and 0 plus 1 is 1. Now when you divide both sides by 2, what you end up getting is 2's cancelling out and x is equal to 1/2. Over here what we're going to do first of all is I'm going to subtract 4 off both sides. 4 minus 4 cancels each other out, and you get 0 minus 4 is negative 4. Then what we're going to do is divide both sides by negative 3, and of course the negative 3's cancel each other out, and the negative 4 divided by negative 3, well, you've got that there. Now of course the two negatives together will end up getting us x is equal to 4 over 3. So what that means is if I substitute in x equals 1/2 or x equals 4 over 3 into this equation up here, what you'll end up getting is an answer of 0.